Hello, ladies and gentlemen. Today we are going to take some notes on adding and subtracting rational expressions where you have common denominators or like denominators already. This is the next page in our little flip notebook there, or our little flippy book, that orange paper or whatever color paper it is. Make sure you're taking on the next page in your notes, okay? So like denominators, we're talking about adding and subtracting. We've already done multiplying and dividing. And remember, our whole big goal is to learn how to simplify these things and do operations with them, simplify them accurately in a way that makes sense or sticks to our algebraic rules. So remember, when we add and subtract regular fractions, one thing we have to have is common denominators. And when they do have common denominators, this is 9/6 plus 5/6, we say our answer is 14/6. How many of each 6 are we talking about here, right? They're the same denominator. So once I add them together, I then reduce, I simplify if I can, and create this 7. I divide the top and bottom by both 2, 7/3, right? Because 14 is 7 times 2 and 6 is 3 times 2, so I can cancel off a 2 and I get 7/3 as my answer, okay? But remember, we have to have common denominators. It's the same idea that when you add for like terms, 3 cows plus 4 cows equals 7 cows, whereas you had 2 cows plus 3 ducks, we can't add those together. We need to have the same type of fraction, 6 in this case, in order for us to be able to add them together. So, in order to add and subtract rational expressions with like denominators, you simply add or subtract their numerators. You look across the top and do what it says. And then we make sure our final answer is simplified. So let's take a look at that first example. This is 7 over 4x. It's not just 7/4 this time, but notice how the denominator is the same. They are like fractions. They are like denominators. They are like terms. So we can add them together and create this single answer where it's just 7 plus 10, which is 17, over 4x. The denominator stays the same. Now we would look at this answer and go, well, is there anything I can do to this? Can I factor out a 2 and divide it off the top and bottom? Do they both have an x in common? And the answer to that this one is no. Okay, so this is my single simplified answer. Let's take a look at number 2. What if I have this for my denominators? I have an x minus 5 and another x minus 5. Well, the good news is they're both the same, right? The denominator is x minus 5 for both of them. Think about that like in our parentheses that we normally would write when we have them in factored form. The denominator already matches, so I don't need to worry about making a common denominator because it already does. I just need to do what this says across the top, 10x minus 15. Notice that's an x and a plain number, so I can't actually subtract those two because they're not like terms. But I can say I have 10x minus a 15 over the same denominator of x minus 5. Now, is there anything that I can do to the top of this fraction to say factor it or anything to make sure that nothing crosses off? Well, yes, out of these two terms, you can divide out of 5. So I'd have 5, 2x minus 3, over the top of still my x minus 5. Now can I cancel anything out? No, right? This is x minus 5. They are joined by subtraction. I can't cancel this 5 with that one, okay? I want to make sure that I cancel the whole factor or nothing at all. So this is my simplified answer for number 2. Okay, let's take a look at the third one. Be careful on this one. We again are subtracting, but we're subtracting 2 terms over here. Notice how the denominator of each fraction is already the same. So we know we already have common denominators. Now we just need to go, well, if they're already the same, let's subtract across the top and do what this says. But notice when you subtract, you want to distribute that negative sign to both terms, and that means this guy's going to in fact become a plus because I'm negative a negative there. And now I can look across this and go, okay, now I'm going to add together these like terms here, right? If I distribute the negative, then I can change this to an adding problem. And I have x squared plus an x subtracting a 12. All of those terms are different, so I have to keep them all separated there. The bottom, I have x squared minus 3x minus 28. Ooh, that's the craziest 8 I've ever made. There we go. So now I need to look at this and go, well, can I factor it and reduce? Possibly. Let's find out. So let's double set parentheses, x's go in the front, right? What two numbers would go in the back to make negative 12 and add to make 1x in the middle? That's plus 4, minus 3. Those will do it, right? And then on the bottom one, I have to do the same thing, double set parentheses, double set. What two numbers multiply to make negative 28 and add to make negative 3? It's negative 7, positive 4. So now when I look at them all broken apart, now I can see that something cancels. This x plus 4 over that x plus 4. So my final simplified answer is x minus 3 over x minus 7. That's as far as I need to take it. Remember, we just added like terms here after we distributed that negative sign after that subtraction, okay? That's the easiest way to do it in this case. Let's look at number 4. Here we are simply going to add two fractions together. Check to make sure the denominators are the same. Yes, they are. Making common denominators is a whole different animal, okay? A whole different video. But let's go ahead and add across the top. So I have x squared and a positive x. When I add across the top, these do not combine. They are not like terms. When you add, you need to have like terms. So this guy and this will just be in the denominator. So 2x squared plus 3x plus 1. So now we want to look and see, can I factor anything here? Is there a possibility that I could break something up here and cross something off? And the answer to that is yes. Out of these top two terms, what can I divide out of both of them? Well, an x, which would leave me with x plus 1. And out of the bottom, this has three terms, so that's a double set parenthesis business there. I need the front to multiply to make 2x squared, so that's going to be 2x and x. I need the back to multiply to make 1, so 1 and 1, right? Plus 1s, check. Inner, x, outer, 2x. Does that add to make 3x's? 1x and 2x? Yeah, that makes 3x's. So I factored that right. Good news is that since I factored it correctly, good stuff happens and these terms stay, but the factors cancel. Okay, x plus 1 and an x plus 1, that whole factor cancels. And we have x over 2x plus 1 as my simplified answer. Okay, so when we start adding and subtracting fractions, we'll be looking to make sure those denominators are the same. Okay, Kincaid out. Thanks for taking good notes, peeps. See ya.